and welcome to this design practice module 18. We are discussing about a CalC case study reported by the electronics systems working group, report by Linton et al, made in 1992. So, we looked into the various aspects of the major elements for a C environment, which included organizational requirements or organizational details, requirement details, communication details, and now we are left with only the product methodology. So, when we talk about again product methodology, as you have already been told earlier, there are various sub elements which relate to how the product development methodology can go within organizations. There could be an optimization based strategy, for example. Here the central theme could be customer satisfaction. So, whatever is done is optimized based on reviews, reviews received from again customers who are the end users. Now, there could be sort of a single requirement based optimization at a certain elementary level of the CE environment, where a certain review which comes or a set of reviews which come are used as criteria for optimization of a certain design parameter. There could yet be another level which we talk about for sort of limited interrelated requirement optimization. So, out of these needs which are arising here based on the reviews, there is some kind of interrelated requirements which get generated, and there are certain multiple requirements of this type which can be used for finally optimizing some themes or adding some optimized themes to the design. We have yet another level where we talk about the same sort of a requirement optimization, not on a single section based requirements, but almost on a program wide scale. So, there also you have multiple requirement optimization strategies which are to be used, and then finally, you have the most desirable C environment which talks about a sort of a weighted requirement optimization. So, here also within the program wide needs which are there for optimization, there can be certain areas which are to be weighted more for optimization, because they would affect the overall order winning criteria in a more appropriate manner in comparison to those which are weighted less. So, there is some kind of a choosing and priority of one over another when we talk about such requirements for optimization. So, this could be one of the basis for doing product development in terms of design changes, etc. So, here we are referring to mostly process libraries or part libraries. The theme here is consistency. Similarly, there are other product development methodology elements like the development process and the controllability over the process, reviews. Reviews may be related to schedule driven product or process critiques, or even event driven reviews, some immediate issue resolution based reviews or status reporting reviews, based on which all these environments can be set in. There are other elements like measurements, analysis, architecture and verification, and you could actually go through all this list here, right, for the different levels A to D for different concurrent engineering environments. Given this, we are now in a position to sort of do the next step or the next phase, which is analysis, and I would like to do the analysis with respect to a sort of a case study which I mentioned here. So, let us suppose given all this requirement from the CalC concurrent engineering facility or group, we are now left with sort of some kind of an optimization. So, we will consider the following example. So, let us say we consider a scenario where there is a program manager of a company, we just call it some fictitious ABC company, who has been charged with the responsibility of developing a line of sort of high quality notebook size computers some constraints have been given based on which he has to typically beat the competition. So, the goal here is to beat the existing competition. There is already a lot of such notebooks existing in the market, and so one has to do a careful analysis as to how the various elements or the influential dimensions can be controlled to place the company somewhere which will take it at a level which will beat the competition. So, the idea is to market with increased features. So, obviously, the first goal here would be to increase the features in the existing notebook. It should be, the pricing should be highly competitive. Okay. So, let us say highly competitive pricing is another goal that overall would be for setting up such a concurrent engineering environment, and this would definitely result in a high market share. So, obviously, when we talk about features, the product must have certain key features. So, the product must have some key features, like for example, it should be a lightweight model compared to the existing which are there in the market already. It should be highly portable. These are features which are almost granted when we talk about notebook sized computers. It should all be self contained in a single casing. There should not be separate keyboard or separate display unit or central processing unit. They are all to be on board on one particular packaging. There should be also some size constraints. So, sized to fit briefcases is what the buzzword is for getting into the world of making these notebooks, notebook size PCs. Generally, it is advisable to have a standard keyboard layout, just so that you could, everybody around the world could use, and it could be an international product with international competition. And then finally, it should have a compatible operating system which is repairable everywhere, or which is troubleshooted everywhere equally well. Okay. These are some of the key features that the product should have. Okay. The assignment also possesses a number of requirements or needs that drive these product attributes and constraints, and let us list some of the product requirements. So, the following product requirements must be met. So, the first requirement is that a low risk approach necessitates the sort of important technology choices that one needs to make, or design reuse and so forth. So, that is what the assignment is going to be of. So, let us say the program manager decides to go for a low risk approach driving technology choices. We want to make it low cost, for example. So, this is very important to have something unique, but at the same time not very expensive. Okay. You can possibly have reuse of the design which is set forth. So, there is also a price competitiveness constraint which would drive material choices, design complexity, etc. So, let us say it should not be too weird in terms of the design, it should have a low price. So, price competitiveness drives aspects like material choices, design complexity, etc. Also the market share, we need to have a high market share, that is the constraint given to the concerned individual. Okay, so high competitive pricing leads to this market share. So that drives the need for a reliable, testable, producible product. So these are the requirements coming out of some of the requirements framed for beating the existing competition by the manager. So let us say we call this market share driven need for reliable, testable, producible products. Some of the aspects then finally which affect the program or the program structure, affecting the program include multiple products underway, at various stages. I mean it could be the concept stage or production phase down all the way up to the marketability sales stage. So multiple products are underway. Okay, that is one of the aspects which might affect the program. You need to produce something which is very unique, and so there should be iterations at almost all levels. So I will say concept through production to all following phases. There can be multiple products with multiple designs. In order to beat the competition and be in business, the pricing model that is made should kind of signify short individual product life. At the same time, it should not jeopardize the quality. It should be that the product design changes quite rapidly, so that there is a need for upgrading the product, because some of the issues like softwares etc. become outdated because of the advancement made in the product after a few years. So one has to discard or dispose of. So that is what short individual product life means. And then of course you should have a long term production capacity. So if it gets discontinued, at least the production should be such which is willing to accept some of these changes as a function of time etc., which gets considered. So given the scenario of the need for marketing a line of notebooks, there is a certain C environment which has to be found out by looking at what is the existing environment which is there and how it should be changed, and this calls for analysis, which is actually the third phase for the CalC workgroups case study. So we will like to look at the analysis part now point by point, so that we are able to figure out what is the existing level of the C environment and how we want to change that, so that this line of notebook can be introduced in this particular C environment. So the analysis phase happens on the basis of the scenario which has been drawn here, and in comparison to what we had analyzed earlier for the various influential dimensions as well as the requirement elements or the elements for the concurrent engineering environment. So let us carry out phase 3, that is analysis, in this particular problem example. So if we use the information on product features, product requirements and some other aspects that affect the program, obviously subjective decisions regarding the levels of all the influencing dimensions on an individual basis are established. This knowledge may also be staying within the organization because of its previous experience in several lines of similar products done earlier. So, the relative importance of the dimensions is considered. This establishes what you call the should be concurrent engineering environment, because the relative importance that is there of the various dimensions would gauge the level of the concurrent engineering environment to be 1 out of the 4, and because of the overall tightness in the competitive environment, it is desirable to move upscale. So, once that level is established, it is not very difficult to gauge what is going to be the next level, for which you have to now draw a set of requirements as per the analysis the elements, draw the elements at certain levels as per the analysis given in the last 2 lectures. So, let us look at the whole map of analysis by finding out, number 1, the relative importance of the dimensions related to the program to be launched, that is a line of new notebooks. Okay. So, we can determine the where am I assessment of the concurrent engineering dimensions looking at what are the most influential dimensions and what is their average level in the existing scenario. So, this is average level or most repeated level. So, let us say most repeated average level in all dimensions. So, given this, the goal here is to understand the where am I and where I should be C environment through the resource planning process, so that adequate resources can be routed into the different aspects which would shape up the different C requirements, okay, C elements. Elements could be requirements, elements could be organizational requirements, product requirements, communication requirements, development methodology requirements, and so you can actually focus on where you want to divert the resources, so that the overall engineering element or overall dimensions can change from a certain level to the next level. So, in this particular case, let us start doing the analysis. We consider the influencing dimensions and their level of complexity one by one. So, considering the influencing dimension and their level of complexity, let us say we talk about the first dimension, which is product complexity. We know in our case the design is highly producible, because it is easier to use only common package devices that are auto insertable into double sided boards, and therefore, there is a sort of an order of complexity which you could say to be little state of the art related to the product line, but may not be exactly as per the product line. So, you could gauge this as level B for the product complexity. So, let us write this down here. So, the design is highly producible. Obviously, we want to make it highly producible because there are repair issues or after sales issues which would only happen in a design which is not too complex. Okay. So, highly producible because only common packaged devices that are auto insertable into double sided boards are utilized. So, let us say the order of complexity is B in this case. Okay. I am going to tabulate this all this later, so that we can have an idea of what is going to be the existing level of the C environment. So, let us talk about the next dimension, which is product technology. Obviously, new application of existing technology is required for the overall product design, because we want to beat the competition. There are already existing lines of notebooks which are there in the market, and if you want to really beat that line, you need new applications of existing technology. Okay. So, obviously, you can't think something completely out of the box, because that may put you at risk. Number 2 is the fact that these are technologies which are not very high lifetime technologies. So, therefore, if you do this in the market once, it may be possible that you are run over by somebody else who will take a sort of a higher level technology, and your product life cycle gets shortened because of that. So, you are investing more and getting less return. So, it is a better idea to sort of have new application of existing technology. So, this is required for the product design. So, we can say that the level of complexity is now B, but it can move to C, where there can be slightly newer application in mind, although not the invention of core technology, new core technology is involved. Okay. So, that is level D. So, we will say that the level of complexity is currently at B, although it may be moving to C to beat the competition. Let us talk about the third influential dimension, which is about the program structure, how the program is shaped to carry out this whole introduction of the new line of notebooks. So, the size of the program staff, including development and production, is moderately large. Remember, we have in our initial criteria laid out, have mentioned that multiple products should be underway at various stages, so that there is always a higher chance of success of the product in the particular market. So, therefore, a moderately large staff is needed for handling such a reasonably big program. So, the size of the program staff, or including of course, people who are involved in the development as well as production, including development / production staff, is moderately large, and that is because of multiple products being underway from various design to production phase, or even down the line sales and marketing phase. So, the program structure is fairly well established, otherwise this could not have happened. and we will have to utilize something which is already there. So, we can use the program structure for this purpose. So, the level of the structure is currently at C, you can say. Corresponding to a level where we talk about multiple locations, formal communication among them, and maybe not a very deep reporting structure, but then certainly manageable level of reporting among the various stakeholders of the program is what level C is all about, which is actually the case here in this case of the company introducing a new line. There is of course some experience from before and some program structure in place already which can be utilized. We now talk about the next dimension of determining the for the particular program that is in question, which is about program future. So, here the investment in manufacturing automation has to be made because of the somewhat new design to the existing designs which are already there, and therefore, there has to be some kind of a planning in place about how the program future would typically look like in a few years time. And so, therefore, I would say that the level of program futures in this case is C. So, let us say investment in manufacturing automation which does not go without planning is in place, and thus the level of program future is, let us say, C. So, we will also talk about maybe in the next few slides in the next module the other aspects of the different dimensions related to again the product line in question, which is about business relationships or resource or schedule tightness or the team scope, so on and so forth. And then we will try to map an overall level for of operation and where it should go to if we wanted to introduce this line of notebook. So, I like to end this lecture here in the interest of time. Thank you very much.